Welcome back to my YouTube channel. Today we will discuss a question of TIFR exam 2025. Okay, question is, consider the following statement for any linear map T R3 to R3 with a two-dimensional kernel. Okay, then H of T is an eigenvalue of T. Okay, and second statement is, for any linear map from R3 to R3 with two-dimensional kernel and x2 x square divides the characteristics polynomial of T. Okay, and question is that which of the following statement is true or false, either both true or one false, one true. Okay, that is a question. Now start the solution. Now solution. Here given any linear map T from R3 to R3. Okay, and given that kernel of the T is two-dimensional kernel, and given that two-dimensional kernel, that is nullity of T equal to 2. So this implies rank of T equal to dimension of V minus nullity of T. We already know this is a famous result, rank nullity theorems. Okay, so that is dimension of V, that is 3 here given, that is 3 minus 2, this is equal to 1. Okay, rank 1. And we know that the non-zero eigenvalues we know that the number of non-zero eigenvalue is less than equal to rank of T. Okay, eigenvalue of T. So that is, we know that the number of non-zero eigenvalue of T less than equal to rank of T. Okay, so here rank is 1. So less than equal to 1. So here eigenvalue, the eigenvalue values of T is either 0 0 0 or 0 0 lambda. Okay, this is only possible of the eigenvalues, because here non-zero of eigenvalue is less than equal to 1. So at most one non-zero eigenvalue of T are consist. Okay, so that is say lambda. So two possible are arise here. One possible is eigenvalue set is 0 0 0, 3 eigenvalue all are 0, and one possibility is 2 eigenvalue are 0 and 1 eigenvalue is non-zero, that is lambda. Okay, now, and we know that the TH of T is equal to sum of the eigenvalue. Okay, so first condition, the TH of T from here 0 plus 0 plus 0, that is 0, and this also eigenvalue. So in this case, in first condition, TH of T is an eigenvalue. Okay, now second eigenvalue set, the TH of T is equal to 0 plus lambda, that is equal to lambda. So TH of T, in this case TH of T is an also eigenvalue. Okay, so our first statement is true. Okay, first statement is true. Now second statement say that any linear transformation from R3 to R3 with two-dimensional kernel x2 is divided the characteristic polynomial of T. So now from first case 0 0 set is an eigenvalue. So characteristic polynomial of T, that is equal to x cube. Okay, so x square is divide x cube, so that x square, this implies a square is divide characteristic polynomial of T. In this case, when one eigenvalue is non-zero, so that is lambda, so that is characteristic polynomial of T is equal to x square into x minus lambda. So this equal to x square divide x square into x minus lambda, so that is x square divide characteristic polynomial of T in this case also. Okay, so this implies x square is divides the characteristic polynomial of T. Okay, therefore this second statement is also true. So here both statement are true, first statement and second statement both are true. So here answer is A. Okay.